I want to share this question with you guys because when I first saw it, I thought the question was going to be easy. However, once I start doing it, I realized how many small things there are that we have to pay attention to. And this question is from the Oxford Math Admission Test. If you want to try the whole test, the link will be in the description. Let's have a look. We are given a sequence with a0 is equal to 3, and we know an is equal to 8 times the previous term to the fourth power, and we are going to figure out a10. And if you take a look at the answer choices, we are dealing with big exponents. So yeah, we have to do this one super carefully. And this is how I did it. Check this out. I'm going to look at a10. Using this right here, we get 8 times the previous term, which is a9, and then we have to raise that to the fourth power. But in order for us to figure out a9, we have to know the previous term, and using this, right? So we get 8 times 8, and then a8 to the fourth power, and then to the fourth power. Okay, so what's happening is this. If you continue, you have to figure out a8, which using this again, you get 8 times a7 to the fourth power. And then on the very outside here, we still have another 4. Yeah, so you just keep doing this until you have a lot of 8 in the front. And then you will see like a 8 and then a0 to the fourth power. And then a lot of the parentheses and then the fourth power like this. Okay, so that's what I did. And of course, right here, we're going to figure out a pattern. It's not bad. I see 3 8s here, and this is a7. 3 and 7 make 10. So that's the pattern I saw. Likewise, we have 3 4s. Okay? So right here, we have a0. That means we should have 10 8s. And then right here, we should also have 10 4s in the power. So just keep that in mind. But here's the part that you have to be super careful now. This is not just 8. This is technically, you will have to put the fourth power here. So you will get 8 to the fourth power. And then for the next one, it's not 8 to the fourth power. It's the fourth power and then the fourth power. Yeah, it's the fourth power square. Because you have 8 to the fourth power, so it's 8 to the 16th power, and then continue. So let me write it out for you guys. All the way in the beginning, we have 8, and then for this one, we have 8 to the fourth power, and then for the next one, we have 8 to the 4 times 4, which is 4 square, and then you have 10 of them, and then that's 8, and then you will have 4 to the 9th power. Yeah, because the first one is 0, and then this one is first, second, and all the way you have 9. Yeah, and now let's talk about how many of the fourth power that we have here. We have a0, and by definition, a0 is equal to 3. So I'm going to put this down in blue. This right here is 3. So we are multiplying by 3. Now, fourth power, but this is not power tower. It's a fourth power inside of a power. So what you are doing is just multiply them. You multiply the powers and multiply the powers. So that's what? 4 times 4 times 4 times 4. So it's 4 to the 10th power. Like that. Okay, so that's how I look at it. Okay. So now, let me simplify this right here because you see that if you add the powers, you get 8, and then you do 1 plus 4 plus up to 4 to the 9th, and then you multiply by 3. And this right here, I'm just going to keep it as 4 to the 10th power for now. How do we figure this out? It's geometric sum, right? So for this, 1 plus 4 plus up to 4 to the 9th power, you can do the following. We can start with the first term, and then we multiply by the common ratio. And because every time we're just multiplying by 4, so the common ratio is just equal to 4. And here we have the nice power. So right here, it goes out by 1. So you put a 10. And then minus 1 over the common ratio minus 1. That's the formula. And to see why this is the case, you guys can check out other video for the proof. Now we'll simplify this a little bit. First, I will write the 4 as 2 to the second power because the answer options, they are in base of 2. And then I will raise that to the 10th power minus 1 over 3. Multiply the powers. So this is what we have. And now notice that here we have 8, which is the same as 2 to the third power. And then we'll raise this to this power, which is the same as that. It's 2 to the 20th power minus 1 over 3. And later on, when we multiply the powers, they cancel out very nicely. Okay, multiply by this 3 here. And now for this 4, we are going to look at this as 2 to the second power. And now, of course, we have the 10th power here. So that will be 2 to the 20th power. So this thing here will be 2 to the 20th power. And here, we can multiply the powers. And in that case, the 3 will cancel. So we get 2 to this power. So it's 2 to the 20th power. And then minus 1. Right, minus 1. But I'm going to write it as times 2 to the negative 1. Right, together, this is the same as that. And then times 3 to the 2 to the 20th power. Now you can see the beauty is that both of them have 2 to the 20th power. So what we can do is multiply the base, 2 and 3. Together, we get 6. And then you keep the power, 2 to the 20th power. And then 2 to the negative 1, you just bring that down to the bottom, so over 2. And this right here is the answer that I got. Yeah, if you have a better approach, please let me know. I think it's just a lot of things that you have to pay close attention to for this one. I don't know if there's any shortcut. I'll be interested to know though. Yeah, that's it.